logging in. My name is Paul Nelson. I'm on the board of the Woodlands Green and your host tonight. Again, I appreciate you coming. I think most of you know Terry, and I'm not going to read the whole thing, but I did want to read the three important things that I know about her, and that's that she's a certified Texas Master Naturalist for 25 years, a lifetime member of the Woodlands Green, and a founding member of the Pines and Prairies Chapter of the Native Plant Society of Texas. And also, she and I have known each other for a long, long time. And there are a lot of other things we could list that she's done and doing, but one of them is continuing to be a champion for education and especially for the kid. And that's what we depend on. I think we'll go ahead and start. Here, if you just want to say a few words, if anybody else, at the end, I'll ask folks if they would like to share with us about any events, especially the Woodlands Green. And then if we can, we can wrap it up with a lot of questions and comments from the chat. So meanwhile, I'd ask you to mute and probably turn off your camera. I will. And Terry, go ahead.
Okay, so I apologize in advance. When I have to have the heat on more than a couple of nights in a row, I tend to get dry, scratchy throat. So I'm a little hoarse tonight. You'll excuse me if I have to take a sip of water. Um, this has been a passion of mine for a while. If you can see my first slide here that's up on the screen, when I lived across the freeway before the Woodlands ever started actually being developed. One day I drove over, as I did frequently, and wanted to take a look at what new roads they were cutting, what new amount of forest they had taken down, what was going on. And on the corner where they had just cut a new street, there was this incredible looking something that was growing. I couldn't for the life of me think what it could be. I got out, examined it, got back in, went straight to the bookstore, went to the field guide section and started flipping through field guides for all kinds of plants, and happened to pick up a guide to Texas mushrooms. Flipping through it, and all of a sudden, there it was. And it's this thing right here that's in the upper right hand corner. It's one of the columned stinkhorns. Its way to get its spores spread is to build up that mass of spores up underneath where those columns meet at the top. It has a truly awful smell that flies and other insects that land on dead meat and things like that, because of the smell, land there. They get that sticky spore mass on them, and then they fly away. Wherever they land, they're leaving those spores. So it's a pretty clever way to spread spores if you're an unusual looking fungi. There are many others in the stinkhorn family, and they're all just as interesting as this one. On this front cover, where I've put a few mushrooms just because I like mushrooms, down bottom left, that funny looking green mass is not a mushroom per se. It is, in fact, one of the lichens. Its common name is a reindeer lichen. And as with all lichens, it's a combination of fungi and either an algae, a blue-green algae, or a bacteria. But I saw it when I was up near Cold Spring one day. It was right on the edge of some timber company property. And I fell in love with the look of it. So I had taken a couple of pictures of it so I could find out more about what it was. And that's what it turned out to be. People who know I'm a mushroom nerd send me photos, and I thank them greatly for allowing me to share some of their photos with you tonight and on other presentations. But tonight, our conversation is about interactions. If you know me, you know that's what I like to talk about, is the interactions that happen in nature that make everything work the way it works. So if we're going to talk about forests and fungi, let's start with forests. So we have to ask ourselves, why are forests so important? Well, I think everyone who's on here knows all the reasons why forests are as important to us as they are. In point of fact, if you want to be alive on this earth, you need trees. They're who provide us the oxygen we need. Might cause us to wonder if trees are what give us life. What gave trees life to start with? Because trees haven't always been here on Earth. Lots of other things were happening long before trees came on the scene, and fungi played an instrumental part in the establishment of vegetation on land. So they have an association that doesn't just span millennia, it spans eons, hundreds of millions of years. Fungi are in the fossil records going back 400 million years and more. So there's a long time association. We'll be talking about some of the interactions. Nonetheless, regardless of all these reasons why we need trees, why we need forests, we have a tendency to keep destroying them. Right now, forests exist on only about 31% of the land areas on the globe. And of those forests, about 30% of those are managed specifically for production. That means they're producing timber or wood, or they're being used for provisions, food, goods, and services. Some places are smarter than others, and they've set aside preserves of forests, protecting them because they have come to understand how vital and important forests are for things like soil erosion prevention and water quality protection. Africa, Asia, South America, some of those larger forested areas, they have protected areas reaching 40% or more of the forest. Not so much here in the United States. We have about 11% of our forests protected for those benefits that they serve. But one thing we know about trees and plants is none of them live on their own. None of them can exist by themselves. And all the same needs they have are all the same needs all organisms have. We call them habitats because they provide those things. But in the case of trees, even though they're considered to be autotrophic, which means they feed themselves, they're not really that efficient at being able to take nutrients in addition to this photosynthesis produce starches and sugars that they make. They're not as effective at being able to collect things like nitrogen and phosphorus from the soil. So they really rely on partners to help them get those things. Most of them are in partner with fungi, especially in larger forest settings. Fungi are very important to help with this, but they're not the only things in the soil. There are other organisms, and I'm sure, again, most of you know that The soil organisms who feed on the detritus, the organic matter that ends up in and on the soil from vegetation, especially, gets broken down. And as those organisms exude or excrete, the changed version of those nutrients ends up in the soil in a more bioavailable manner, so that not only the trees, but even the fungi can better absorb them and use them as a food source. Most of these partnerships are considered symbiotic, which means that all the partners benefit from the association and the interactions. In this case, that means that the trees are getting something they need, but the fungi are also getting something they need, because as part of that photosynthesis, producing those sugars, carbs, trees are like every other single organism. Everything that takes in food has to give off waste. And in the case of trees, what they have most of that they exude as waste through their roots are those carbs and sugars that they create for themselves through photosynthesis. But they also have chemical makeup that is able to convert those carbs into glucose. And glucose is the preferred form for those sugars that the fungi want as their food source. So it works out really well for both parties that the fungi are right there. They are able to take in the glucose while the plants get nutrients through the fungal association, those nitrogens and phosphorus things that they need. So some of the things we know about fungal networks, there's a lot of research that has helped us understand that these interactions are happening. They're different depending on the species of fungi, depending on the species of tree. Not all trees associate with the same fungi and vice versa. And not all fungi are in association with the tree. Some of them are networked with other fungi, and their job is to also participate in that decomposition, and they pass along those nutrients to the fungi that do directly interact with the trees. And if you notice here on this, I've commented that mycologists know that some fungal interactions are beneficial. So you might infer that I'm saying that there are some fungal interactions that are not, and there certainly are. Not all fungi are good guys in the forest, at least not as far as the trees are concerned. Some are pathogenic, but not all the pathogenic fungi are in the soil and have a direct association with the roots. Sometimes it's flying insects. And here in our forest where we live, we're mostly in pine and pine mixed forests. So I know you've heard about the problems of pine trees with pine bark beetles. And it's not that tiny, tiny beetle that bores in through the bark that can kill the tree, but it's the fact that it bores in through the bark into that one cell thick layer of living tissue that's right beneath the bark. It chews its way into tunnels and galleries, and that's where it lays its eggs. And those insects, as well as the other boring insects that attack other kinds of trees, have organs that are called mycangia. That's where they store fungal spores. So when they lay their eggs in these tunnels, they use their saliva to leave some of these fungal spores that begin growing. And as the larva emerges from the egg, they have food because they're not ready to eat a tree yet. So they need that fungus. And the better it is able to grow, the better the larva is able to grow and progress through its stages until it's ready to emerge back through the bark and go off and start the process again in another tree. But what makes the tree weak and can even kill it is the fact that pine trees, all trees, have this ability to emit chemicals into the air that says to their neighbors, especially those of the same species, hey, bad things are happening over here. And those terpenes that pine trees emit have the negative effect of notifying all the pine bark beetles in the area, hey, there's a tree in distress. Let's head over there and see if we can't drill through that bark and lay our eggs there. It's the proliferation of those boring insects into the tree, all of them filling cavities with this fungus that is pathogenic to the tree and can overwhelm it. So the tiny insect making that hole is not what kills the tree. It's all the fungus that grows inside. So yeah, not all fungi are good guys in the forest, but there we go. I mean, we get what we get. So when we look at these images, these are kind of standard images that we all see that show us how things interact with each other. You can see the illustration here showing the kinds of networks that you might find. What we might not always realize is that these beneficial interactions rely on an established coexistence between the trees, the other soil organisms, and the fungi. These are associations that have been in the same place, again, not just for millennia, but for eons. All of these organisms in concert have adapted to one another and learned how to benefit one another in this network, in the soil. What this means is the greatest threat to forest health we have now is the introduction of non-native invasive species. Because let's think about that. This is a plant that comes in, it hasn't had these associations, it hasn't had these adaptations. It's going to drop its leaves, and maybe or not, those soil organisms that typically you may use the detritus for food so they convert the nutrients into a more usable form, maybe they can't eat those leaves. Maybe, in fact, they die if they eat those leaves. And what about the exudates? Everything that takes in food has to give off waste. And the same is true with those invasive plants. Are they going to have different chemicals that they exude into the soil through their root system? And is that going to alter the decomposing community that existed there before? Is it even going to damage or kill off the fungi that the trees have associated with before? And how pervasive is this problem going to be as those invasives begin to create their own soil situation so they can advance through the forest? More and more of the organisms in the soil, including the fungi and the trees themselves, are going to die off. So changing the soil makeup and disrupting the decomposing community, breaking those network connections, all of it ends up with a detriment to the forest. We know that fungi access tree roots in a lot of different ways. Some of them are listed here. They're kind of interesting how trees have to accept the fungus, and the fungus has to be a willing partner of the tree. Again, because here near us, the primary forest makeup is mixed pines with emphasis on the pines. The most common species of fungi are called ectomycorrhizal. Ecto means they're on the outside, myco for mushroom, rhizal for root system. These are fungi that, in their association with pines, tend to grow their hyphae around the roots. The hyphae are those hair like spider webby looking strands that, I guess, for the mushroom growth, you could liken to the tree's root system. But they grow their hyphae around the roots and create this net around the entire root system to make it more, I don't know, economical and efficient for the tree and the fungus to exchange the nutrients, the sugars, whatever, the water, whatever they're going to exchange. And some foresters in past have been concerned, wondering if that net around the root system was either going to stunt growth or might it prevent the trees from accessing more nutrients or water on their own. So it turns out those worries are really unfounded. The roots of the tree can continue to grow. The mushroom just grows its hyphae around the new growth to keep it protected. And yes, it does mean that the tree is completely reliant on the fungal net that's around it to provide the nutrients and the water that it needs. It does mean that. But it also means the fungi are there to protect it. They can stop invasions by insects or diseases. They can even help trees live through droughts. Okay, well, that's kind of a bold statement. And do we know it's true? I think it was a university in Kansas or Missouri. They wanted to find that out. So they took some northern grass seedlings. They put them in containers with sand. Half of the containers they inoculated with the kind of fungi that typically associate with those grasses, and the other half did not have the fungus. They were not colonized. So the seedlings were in the sand on their own. And then they subjected the roots of those seedlings to 10 days of 120 Fahrenheit degree heat on their root system. Well, the grass seedlings that did not have the fungi in the sand all died within 3 days. The ones that did have the fungi in the sand not only survived the 10 days, but thrived afterwards. So it's pretty sure that the one thing we've assumed about fungi being able to help provide the water and the nutrients during times of drought looks like it's absolutely true. And this is kind of the way we learn about these associations, learn about fungi, learn about the networks, because, I mean, face it, we can't just look down in the soil and see these things happening. And that's one of the main reasons why we don't better understand how and why these interactions actually happen. A few months ago, I read a book that was, I thought, fascinating. You're probably going to laugh when I show you the title here. It's called Biocomplexity of Plant Fungal Interactions. Okay. Maybe it's just me. But this is a compilation of, I don't know, 10 or 12 different research reports, papers, articles that were written by mycologists and scientists and researchers trying to get a better handle on understanding these plant fungal interactions. And the very first little chapter, if you want to call it that, in the book is kind of interesting to me because it puts forth a theory about maybe one reason we haven't learned as much about fungal and plant, tree, forest interactions as we could have. I mentioned earlier, we've seen fungi in the fossil records that are 400 million years old. So we knew they were here long before land plants. But we all tend to like the bright, shiny, pretty, perfect things. I mean, think about you walk along the beach, you see a shell. Okay, the sea worms have drilled some holes in it. Yeah, walk on. Then you find that perfect angel wing shell. Oh my gosh, it's beautiful. It's perfect. I got to take it home, put it up on the mantle. These guys writing this first chapter in this book make a point that we all love those perfect, bright, shiny things to look at, to study. And about 2 decades ago, some of them started looking in the storage cabinets and the bits of fossils thrown in drawers, taking another look at them. And guess what? As with so many other things, technology has become so much more advanced. Now, when we look at those tossed aside fossils from before, we can actually see those microscopic fungi and determine to a surprising extent what they're actually doing in association with plants. There apparently are even some of those fossils from which DNA has been able to be extracted. So they can even get a better handle on those associations, those interactions, and the way that fungi helped land plants not only get established, but progress through time, grow, change, adapt, evolve, if you want to use that word. And I don't think there's any doubt that those adaptations and changes and progressions are probably still happening, but they happen at such an incredibly slow rate that none of us are going to be around long enough to notice that this pine forest now looks different from what it did 200, 500, a million years ago. So they're working more now on some of those less wonderful, beautiful, pretty fossils and learning amazing things. Darlene Southworth is the editor of the book that I've mentioned here on there. She used the word amazing in talking about the new research and the new findings that are happening every single day, looking at those fossil records now with our new technology. And I had to laugh at some of what she wrote in the introduction to the book. She comments here, and I'll read them with you. Plants tend to have an open architecture that can be altered morphologically and anatomically by fungi. Okay, we knew plants could change, but I don't think we realized that fungi could affect that change before they began to examine some of these fossils more closely. Okay, that's kind of new and interesting. She says more and more interactions between plants and fungi are widespread and important, although we previously overlooked them. We have better technology. We can discover things we never even guessed were happening before. And they are wonderful things. And then the one that made me laugh, and I'm quoting her verbatim because it's just so amazing. Ignorance of plant fungal interactions does not make them irrelevant. So, new research, we're going to learn a lot. I hope I'm around to hear some more of it than this book, but I've thoroughly enjoyed. I should have included a picture in a slide, but it's Biocomplexity of Plant Fungal Interactions. It's amazing book. I thoroughly enjoyed it. So, is there anything we could do? Is there anything we collectively or individually can do to help with our local forests, make a difference in their health? Well, don't forget what I said earlier. The greatest negative in our forests is the introduction of invasive species. Right now, today, 44% of the forests in the world are comprised of non-natives. Here in the United States, apparently we've done a little bit better job. In the United States forests, only 3% of the forests are made up of non-natives right now. Maybe that means it's still early enough with a dedicated effort to improve our forests, to help monitor, control, remove those invasives, give the forests a fighting chance, because they're going to need all the help they can get. No matter how you think about it or what you believe about it, the climate is changing and our forests are moving. They're at the front of the forest, whether it's headed north, south, east, or west. As the climate is changing, it's advancing. You have to ask yourself, how quickly can the soils, the organisms, the fungi, the trees themselves adapt? Will they be able to survive it? Temperatures are changing so quickly, there's a real possibility that forests, although they're trying to move to stay in the kind of zone they want to be in, they may not survive. And right now, the trees at the back of the forest, depending on whichever direction it's moving right now, the trees at the back of the forest are already in decline. Many of them are already dying. So the board of the Woodlands G.R.E.E.N very recently considered what are some of these issues in forests that we might be able to affect in a positive way. And of all the things we looked at, helping to monitor, control, and remove non-native invasive species turns out to actually be a relatively easy way to help our forests. I mean, many of us have already taken the classes to learn about invasives and to learn the protocols to monitor and report that data in, so that the researchers who are trying to keep ahead of invasions by non-native species can anticipate where they're moving and how they're affecting vegetation, whether it is forests or fields or prairies or whatever kind of grassland. That's something we can do. And you may already be aware that for the past several years, the Woodlands G.R.E.E.N has been the management organization for removing invasive species in this area. I think Lisa Houston, I saw check in here tonight. She currently is the lead, and she's the one who sends out notifications about work days and locations and kind of organizes the groups. But recently, the Woodlands G.R.E.E.N board has developed a firmer, more well-connected partnership and collaboration with Heartwood Texas Master Naturalist and with W.G. Jones State Forest. And we have begun scheduling many of our educational events there. We're doing litter control on that forest, litter control, and doing audits so we can report that data in on the litter that's there, all to help keep our waterways healthier, keep those pollutants, that trash, especially plastics, out of local waterways by getting them out of the way while they're still on land. And we will very shortly be setting dates to do some trainings as well as some invasive species removal on the forest. They they're not overrun yet, but they do have quite a bit of invasive species right now. So we're going to start working there as well. There are some other things that are happening in this new collaboration, including some demonstration gardens and other activities that I know you're going to be excited to hear about as we begin announcing them. But the board of Woodlands Green developed some statements that we thought were important for us to consider. And then we took a pledge. We promised that we would learn more about invasives, get more active in helping remove invasives, and if circumstances prevented our being as much hands-on as we would like, it's an and or situation that we would make a monetary donation. Each of us would make a monetary donation in addition to our annual dues that we pay in to help us buy more supplies, have more educational events, and really beef up our efforts to protect our local forests from invasive species. You might notice there's a QR code on this slide. It's the link to the pledge we took. And the entire board would like to invite all our members and all of our friends of the Woodlands Green to consider taking a look at the pledge. There's no pressure. There's nothing negative if you don't want to do it. But we're asking you, we've done this because we feel so strongly about it. Would you take a look at the pledge? Would you take a look at those 3 statements that we included? And even if you don't pledge, would you please give us some feedback on the choices are, I agree, I disagree, or I'm not sure. And the only thing we ask is if you would answer those and give us your name so we can get a better sense of how other people think about this problem. And then there's a place to sign. It's optional. If you don't want to take the pledge, don't take the pledge. If you do want to take the pledge, thank you so much. And if you don't want to get hands-on involved, would you even consider then possibly making a donation to Woodlands Green so we can earmark it to help with this kind of project that we really want to expand in this area? I'm going to show you the next slide that has the website. It's just thewoodlandsgreen.org. If you care to make a donation, when you go to the website, you can scroll to the very bottom. There's a button to make a donation. But up top, when you very first go to the website, there's also a little place on the top menu that says Take Action. When you hover over that, the menu that drops down offers quite a few other ways, and more are being added all the time, that maybe you'd like to get involved, but this isn't something that interests you that much. There's plenty of other choices you can make. Love for you to visit the website if you have not. See how you can learn more about our local natural resources, learn how you can volunteer to help us in protecting them. If you will, I'm going to go back and ask you to consider using the link, take a look at the pledge, make a decision. Thank you for your consideration, whether you pledge or not. But we would love to know your thoughts on the pledge. We would love to have your joining us. And so again, I say the board invites you to join us who have taken this pledge and who are promising to get more involved. Thank you for listening. Paul, do you have any questions for me?
Thank you. I don't see anything in the chat about our questions or comment. I did of course, have a few questions. One of them is like, I've read maybe 1 million species or something. That's outrageous number of. Is that accurate? That many?
For what? How many
Mi-
species of what?
1 million species of fungi.
Um, it depends who you ask. There are a lot of folks who think there may be as many as 10 million species of fungi. But what we've identified is something like 5,000. So,
Right.
you know, we don't know. Every day they find a new fungus somewhere.
Yeah, this is worldwide that I was talking about. But
Yeah.
and I also had a question about the spores. Uh, by definition, do all the fungi reproduce that way by spores, or are there other methods of?
So even those that live entirely in the soil and never produce above ground mushrooms still do rely on spores. Um, if Paul, if you could see the tens of millions of fungal spores that are released into the air every year, and they were all in one place, they would cover a land area about the size of Africa
Oh.
every year with spores. They
And I guess some of them are, we think about the seeds and things like that causing allergies, but a few of the fungal spores can cause allergies in humans. Is that right?
so I'm sure that's true, but worse than that,
Yeah,
there
it could be
are
worse than.
fungi whose spores out there in the atmosphere can be breathed in, and some can even grow fungi in your lungs. Others
Right.
can bring on diseases. There's a problem right now with all these fires, people moving around, and um, it's called yellow valley fever, and it's caused by inhalation of mushroom spores. So there are, I said earlier, there are definitely bad guys in the fungal world out there. Um, that's one of the reasons why it's such a good association for fungi to protect trees and plants, is because fungi themselves can be antifungal in nature. They can prevent other fungi from attacking trees and plants and vegetation in general when they associate with them. Paul, I'm seeing a question in the chat asking about those dinner plate size mushrooms after a rain. Those, if they're in your yard, if they're in like turf grass or a manicured yard, chances are good they are um the name will come to me. Don't forget, I have this short-term memory thing that goes on. They are lepiota. Um, if you went out and pulled the top off the cap off the stem and put it on a piece of white paper and covered it with a bowl and left it overnight, you'd probably be able to see that en masse as the spores dropped out, the color of those spores is a greenish kind of a color. You do not want to eat them. They are quite toxic. They probably won't kill you, but after a few days of diarrhea and vomiting, you might wish you were dead. But they are very dangerous for small people like children and pets if they eat any of that mushroom. So if you have animals or kids that tend to pick stuff up and put it in their mouth in the yard, you might want to take a grocery bag, put your hand down in it, pick the mushroom, bring the bag around it, tie it up, and just throw it away. But they tend to grow in a circle in your yard because
Yeah.
that's the way that mushrooms grow. They grow from more or less a central point out in kind of a circular fashion, and it's always out there at the tips of where the hyphae are growing that the mushrooms, the fruiting body of the fungus, spring up. I know I've been in forests before, and I've noticed a couple of mushrooms, and then I walk and I see a couple more, and they're all alike. And as you stand back and look, you realize you're seeing a line of them. And if you could get up high enough over the forest, you'd realize it's a gigantic ring, because that fungal growth is that big and it's fruiting all the way around its edge. So those circles, or even those individual ones that come up, that they tend to have little brown speckly things on the top. They're more or less white. Yeah, don't eat them. I suggest you don't touch them, but you can always make the spore print to verify that they are Lepiota. They're not so good. Someone else is asking about books on local fungi. Sadly, there are very few books that really cover local fungi. The Metzler's book, it's called A Field Guide to Texas Mushrooms by Susan and Van Metzler. It's out of print. It was printed a second time with a different cover from the original, but it wasn't an update. It wasn't a new edition. It was just a second printing. But it's now out of print altogether. Sometimes you can find them used, even on Amazon or in used bookstores. On Amazon, I've noticed that when they come up, people want 2 arms and a leg for them because they're so scarce anymore. But they are truly the only real guide to mushrooms in Texas. David Lewis, who was a longtime member of the Texas Mycological Society, which is how I got started in mushrooms for all those years before it disbanded. He lives up in the Big Thicket area. And he and Alan Bassett have, in the last, 5 years or so, written a terrific guide to mushrooms of the Texas Gulf Coast. The problem is, in the Metzler's book, they group families of mushrooms together so that even if you don't know what you're looking for, you can kind of flip pages. And if you see something that kind of looks like what you're looking at, you can go back and forth, and often you can find what you're trying to identify. In David Lewis' book, all the mushrooms are listed in alphabetical order by scientific name. So if you don't know the scientific name already, it makes it difficult to find. If you have a clue about the scientific name and you still can't find it, look in the index, because those darn lumpers and splitters, so many of the mushroom names, like all other things, have had their names changed. So sometimes you can look up the old name and it's in that index of David Lewis' book, and it refers you to what the new name of it is so that you can look it up. Okay, and Christine Nispinsky is sending us a link. If you're in chat, maybe we need to open chat so everyone can see it. I don't know if everyone will be able to see it after the fact. Let me copy it and put it back in. Okay, somebody tell me if you can see that now. But it looks like a really fun thing. It's Learn to Draw Mushrooms with John Muir Laws. And there's a link to it there. So if you want to have some fun, maybe you could try that. Can you see it in the chat now? Someone who's not Paul, anybody see it?
I do not see it.
No.
I can see it now. I was going to ask you to
But you could see it before, Paul.
turn it
No,
on.
we can't.
Send it to everyone. I guess I could try it again. Does anybody else have more questions? I'm not seeing.
Yeah, I do have a question.
Daniela.
Okay, Daniela, go ahead.
Yes. So I have a first question about the fungi. So we're trying to protect fungi because fungi make an impact on the forest from the bad mushrooms. However, I mean fungi, sorry. Does it make an impact if we remove the bad fungi? Like, is that going to be an impact towards the environment? That's my question, if that makes sense.
Well, so here's the way I see the problem. To remove a fungal growth in the soil could be very far reaching. You have no way of knowing until you begin digging around how expansive that fungal growth may be. If all you're talking about is removing the mushroom, the fruiting body, that's one thing. That's like picking an apple off a tree. It's not going to kill the fungus. It's like picking an apple is not going to kill the tree. But if you decide you're going to start excavating to get all of the fungus out of the soil, you're probably disrupting a much larger fungal network and the connections to vegetation that they have. So I can't imagine it would be practical for one thing, because it would be extremely difficult to find all pieces of it. And if you don't get it all, it just regrows, but you would probably disrupt beneficial fungi in the process.
Got it. Thank you very much.
We've got about 5 minutes left. Anybody have questions?
I had one of the books you suggested at another meeting that I was privileged to attend was Teeming with Fungi, the play on words, but I bought that book at your recommendation, enjoying that. That's
Jeff Lowenfeld's book, Teeming with Fungi, is
about soil.
a really good read about how fungi enhance soil for all vegetation. Right. If you're a gardener, knowing about fungi would be something really good to know, and ways to introduce fungi into the soil.
Yep. I'm enjoying it.
Another night.
So, would you take the time to tell us about your next mushroom walk? I think I attended one a few weeks ago, learned a lot.
So Saturday morning, February 1, meet me at the classroom building at 9 a.m. on W.G. Jones State Forest. It's on 1488. W.G. Jones State Forest. If you enter not in front of the office building, but at the next entrance, that's about 1 mile west of Highway 45, there's parking spaces and the classroom building is there. We'll talk for a few minutes, answer questions, talk about what we expect to find. We were out there in December and we found some fungi, but it hadn't rained. We'd had a really long dry spell. Well, that certainly has changed now. And with this cooler weather moving in, some of our fall and winter fungi will not fruit until the soil temperature reaches a certain low level. So, and we're not talking about air temperature, we're talking about the soil temperature. So now we may see fungi that we only see in fall and winter. So 9 a.m. in the classroom building on February 1 at Jones Forest, and bring a bottle of drinking water and wear your best walking shoes. And let's talk about mushrooms for a minute, talk about why we might expect to find what, and then let's head out. What did we spend? About an hour or maybe a little bit more, Paul, last time. And we found mushrooms. I mean, we found quite a variety, but they were mostly bracket fungi and not the fleshy sort. We did find a couple of very cool looking amanitas. No one picked them, thank you. And so we might find something else.
Are you asking that folks,
if you have a question,
register? Are you asking?
Yeah, John has been sending out links to register. If you don't find the registration link, feel free to just show up. If you have a question, again, my email address is here. If you want to send me a question about the mushroom walk, please do. I'll be happy to reply as soon as I can.
All
I
right,
think we're almost out of time. If there are any last questions.
nothing else. Well, again,
If you
thank you
will,
so much. As usual, I said I never visit with you without learning something. And I know everybody appreciates what you do.
you're too kind, Paul. I've put back on here in case there was someone who still wanted to take a look at our pledge to help with invasives in our local forests. And I thank you again for listening tonight. Consider the
Yeah.
pledge, please. Join us in
And I
this.
was, before we left, I was gonna ask if, I know Lisa's on the call, I think, but whether there was anything planned for the invasive species at this time, or Lisa?
No, we don't have any dates scheduled at this point, but everybody stay tuned. I'll be sending out a letter here shortly just to make sure that everybody's on my list wants to remain engaged. And then we'll be moving forward. And we, as Teri said, we will be working on some invasive species event in conjunction with the forest as well. So stay tuned.
Thank you. There's nothing quite like as satisfying as tearing down air potatoes or tallow trees. And I can name a few
Amen.
more, but it is a rewarding project and that gets you outdoors. Thanks, Lit. Appreciate it. And I appreciate everybody for coming. Thank you so much, Teri. And this has been recorded and will be on our menu of past recordings. John will put it on the website. And I urge you to tell people about it, have them come to the site. We have at least a year's worth of presentations that you can view or share with others, especially share. Appreciate that. With that, Teri, I'll say good night, everybody. Close her down.
Good night, everybody. Thanks for spending time with me.
Good night.